Hey guys, this is Murtaza from Networkers Home. In this video, we'll talk about VPNs. What is VPN? Why do we need VPN? What are the types of VPNs and what are the protocols to secure the VPN? So first of all, let's take a look on the definition of the VPN. So it states that VPNs, also called virtual private network, creates a secure network connection over a public network such as the internet. So it allows devices to exchange data through a secure virtual tunnel. When we apply the security over the tunnel, then it allows the devices to exchange data through a secure virtual tunnel. It uses a combination of security features like encryption, authentication, tunneling protocols, and data integrity to provide secure communication between participating peers. That means CIA, confidentiality, integrity, and authenticity. You can see. I'll explain that to you in a while, but first of all, let's talk about what is VPNs. So when we talk about VPNs, it doesn't mean that we are securing our network. It is mentioned over here over secure network, but it only gets secured once we apply the security protocols over the tunnel. So for example, I have an office, for example, in, let's say, Bangalore. This is my Bangalore LAN network. And for example, I have different floors. This is a different multiple floors building. I have one sales department on one floor, IT department on one floor, management department on one floor, and the administrative block at one floor. So for example, these are another floors and this is another floor. And they are on the network, for example, as 10, 10, 10, 0. So for the communication of these floors or these departments that are in the same building and on the same LAN, that is 10.10.10.0, they don't need any kind of internet or they don't need any kind of VPN connection so that they can communicate with each other. Pardon me with the spelling over here, it's Bangalore, not Bangalore. So anyways, let's continue. So they don't need any kind of internet connection. This is my private network. I don't need any VPN or internet connection for these departments to communicate with each other. Now, let's say I have expanded my office and I've opened another branch in, for example, let's say in Kashmir that I am from. So here also I have multiple offices, multiple departments in my office. Let's say IT department, sales department, management, and administration, and a few more. And now they also don't need any kind of VPN or internet connectivity in order to communicate with each other. Now, what I want is I want my two offices to get connected to each other so that they can communicate IT. For example, this is, if it is IT and this is IT, I want my IT departments of my two branches, that is one branch in Bangalore and one branch in Kashmir, to communicate with each other. And I want my sales department of Bangalore to be in touch with the sales department of Kashmir. So the possible communication that I can make between, for example, if the distance between Bangalore and Kashmir is 3K kilometers, and that's a lot of distance. So for example, one way possible is to do the wiring. We can ask any service provider to do the wiring and connect our offices, but we have to keep in mind everything: the cost, the reliability, the maintenance. Of course, the maintenance is not our problem, but overall it will affect us, because if if the wire gets tampered, if the wire is cut in between Bangalore to Kashmir, there's a lot of cities they'll be covering. So if anyone cuts the wire, or due to some natural calamity, the wire is broken somehow, so it will cost us in terms of business, in terms of communication. So we have to keep in mind everything before we choose this connection, because it will, of course, it will cost a lot to do the wiring from Kashmir to Bangalore, because this will cover a huge distance. As I said, for example, it's 3,000 kilometers. That's a lot of distance. It's kind of impossible, not impossible, it's possible that, but it will cost huge money. So rather than taking the help of service provider to put wires and connect our two offices from Bangalore to Kashmir, what I can do is I can take the help of, let's say, the ISP. This is my ISP, and what I am doing is I am taking the help of ISP to connect my Bangalore office to Kashmir. And for that, what we need is we need 2 layer 3 devices on our offices. I mean, we need an edge router. We need either it can be a router or it can be a firewall. So either we need a firewall or we need a router, so that we'll be able to do the routing, because our switches, our LAN devices are not capable of doing the routing. So what we need for the creation of VPNs, we need L3 devices, be it a router or in this case ASA, or any kind of VPN, any kind of a firewall. So what we are doing, we are connecting our LAN to our L3 edge device, we can say, that is connecting to the internet, and we are making a connectivity from this side to the L3 device of Kashmir branch, and we are connecting this L3 device to our Kashmir branch LAN network. So this is the possible connectivity that we can make. And what we want is so we'll take the help of VPN. We'll create a VPN instead of doing the wiring like this over the 3,000 kilometers. But that's not a feasible solution. We have to think about the cost, the reliability, the maintenance, the downtime, and everything, the natural calamities. So because the cost is the major factor in this. So we have to think about everything, the budget and all. So with the help of the ISP, we connected our L3 devices to each other, and on these L3 devices, what we need is we need static IP addresses on this side as well. Static IP addresses. And now you must be thinking, why do we need static IP addresses? So when we create VPNs, the site will have to define the destination to with whom it is going to create the VPN. So if we don't have a static VPN, sorry, static IP address on the other side, how will I be able to say what is my destination on the other side with whom I am creating this VPN? So it only depends when you're doing site to site VPN. In case of remote VPN, one site can also be a dynamic VPN. But in case of site to site, I'm talking about site to site here. So in case of site to site, you need to have static IP addresses assigned. And now the other thing that we have to look at when we are using L3 VPN, sorry, L3 devices to connect to the internet, they must be having a public static IP address that I wrote over here. This is public static IP addresses on both the sides, so that we have the connectivity to our L3 device of Kashmir branch from L3 device of Bangalore. So I can communicate from this site to this site because we have a public static IP addresses on our LAN networks. What we have is we don't have public IP addresses over here. We have static IP addresses. So for example, when I want to communicate from Bangalore branch to Kashmir branch, the source will be, let me create this, let me show you. For example, this is 10.10.10 and for example 1. And this is over here, it's 2020.0/24, and the destination, for example, is 20.20.20.1. Or let's not write this up in mask for now. So for example, I want to communicate from Bangalore. IT department user is trying to communicate to IT department of Kashmir, and this is the source and this is the destination, source and destination, and they want to communicate with each other. So when the packet, let me do it in a clean way so that you'll be able to understand it easily. Let me connect these. These will be connected like this. And this will be connected like this. This will be our, let me increase the font. This is, for example, a router. Let's consider it as a router 1. And let's also put it as router 2, for example. So over here, the network is 20.20.20/24. So when the IT department of Bangalore, a user from IT department of Bangalore wants to communicate to the user of IT department of Kashmir, the source will be 10.10.10.1 and the destination will be 20.20.20. For example 1. Now this is the source and this is the destination. So when the packet will reach to your L3 device, it will check the destination, and it will, because on our L3 device we'll be having a default route towards the ISP. So the packet will be forwarded to the ISP, and when the ISP will check the source, the destination, on the basis of destination, the routing is done. When it will check the destination, it will see that it is a private IP address, and the packet will get dropped on the ISP itself, because private IPs are not routable on internet. So for that, we're using public IP addresses over here that are assigned by the ISP to our edge devices. So we have some public IP addresses assigned to our L3 devices over here. And with the help of that, we are able to communicate from one site to another site. So For example, let me write the public IP addresses over here. For example, this is 192.168, it's 1.1, and the IP address over here is 192.168 2.1, for example. And with the help of these two public IP addresses, we are creating a tunnel between our L3 devices. So only with the help of the public IP addresses, we are able to create a tunnel. So because the prerequisite is you should have the routing, you should have the reachability to the other side, because if you don't have the reachability to the other side, you won't be able to create the tunnel between your L3 devices of two offices that are located in different locations. So now that we have created the tunnel between R2 and R1, this is our actual data, this is our actual packet, it will go to R1, and this will go through the tunnel to R2, and it will reach to the IT department of Kashmir, and the reply will come in the same manner. The source and the destination will be vice versa, and the reply will come through the tunnel back to the sender. So now that the communication is made possible, we are communicating from private to private over the public network. So whenever you think about VPN is always about the private communication over the public. So what I mean to say is that whenever you think about VPNs, you'll see always the destination and the source and the destination is private. Otherwise, there is no need of creating a VPN. So VPN is connecting two private sites to each other over the internet, because you can see these are two sites, and we are communicating to our two different private sites over the internet with the help of a VPN. So now that we have created VPN, we have to think about CIA. So what's CIA? CIA is confidentiality, integrity, and authenticity. Also, you can say authentication. So what does authentication means? Authentication means it verifies that a packet received is actually from the claimed sender, from the authenticated sender. So it verifies the authenticity of the sender, who the sender is. If that sender is the one who had to send the packet, if it is the real sender, not a rogue sender. So it checks the authenticity of the sender. And some of the methods are pre-shared key, with the help of pre-shared key, or with the help of digital certificates. These are some methods that can be used for authentication, that can be used for the authenticity of the sender. You can consider, I can give you an example, like in your office, you might be having a security guard down at the gate. He will be at the gate. And whosoever is coming in the office or in your house, wherever the security guard is put, or in your society, he is asking for, he always asks for the identity. So first, before allowing that person or anything, that packet into the network, the security guard is first of all authenticating the sender, whether the person or a packet that is being received is actually from authenticated sender. So for that, we are using in real life, you're using, for example, in case of a society, the security guard checks the identity card of the sender, of the person that wants to go inside the society or into the office. So same way, to check the authenticity of the sender, we use pre-shared key and digital certificates. These are some methods for the authentication. So the second thing, integrity. It ensures that the content of the packet has not been altered in between by the man in the middle. So for example, you have two sites. For example, this is one site and this is two site, and you're sending back and forth some packets. For example, if you have if someone connects their laptop or any PC, whatever, and they try to sniff your packet in between. For example, if you're sending packet from A to B, and for example this is C, what it will do when the packet is when the packet will go from A to B, it will sniff the packet. The C, this is a rogue person device. It will try to sniff the packet, and it will take the packet, it will copy or whatever he wants to do, and then after doing what he wants to do, for example, he will copy all the data, all the packets, and then he'll send it to B. When B will receive it, the rogue router, the rogue device will send it to B as if A has sent it. So nowhere in between, nowhere any of these two sites will understand the packet has been sniffed if we don't have integrity. So if A is sending the packet to B, the rogue device will sniff the packet. The hacker will sniff the packet. It will copy it into its own database and send it to B as if A has sent it. So B will never get to know if the packet has been tampered in between. And for that, we use integrity. So it ensures that the content of the packet has not been altered in between by the man in the middle by the help of hashing algorithms that includes MD5, SHA-126, 256, and all. So a hashing value is calculated on site A. When the packet is being sent to B, a hashing, it's a hashing number. For example, you can say a hashing algorithm is done on the packet. For example, this is the packet, and I have done hashing on this, and the hashing, for example, number is 123. For example, so this packet will be sent to B, and when B will receive it, it will calculate the hashing, and it will calculate the hashing algorithm. It will calculate the integrity for this packet that has been sent. It will see this is 123. Now, when we have a man in the middle attack, and it has taken the packet and copied it and sent back to B, when B will receive it, it will do the integrity. It will check the integrity hashing number. It will see that it is getting a hashing number of, for example, 2, 3, and 4. So now that he can see that the packet and the hashing number that A has sent me is different from the packet that he has received, and the hashing number he has received, he'll get to know that the packet has been tampered in between, because this is not the same that has been sent by the sender A. So the other side will get to know whether the packet has been altered in between or not. The content of the packet has not been altered in between. So for that, we use MD5 and SHA. The third thing is confidentiality. What confidentiality basically means is it encrypts the message content through encryption so that data is not disclosed to unauthorized parties. So when we have site A, site B, and the man in the middle sniffing the packets, you make sure when you're trying to send data back and forth, if any unknown person tries to sniff your packet, he'll not be able to understand that packet, because we are encrypting that packet. For example, I'm sending some traffic A from one site to site 2. If the packet is getting sniffed by the man in the middle, he'll not understand. He'll understand AAA. Now, if we apply confidentiality, if we do encryption on our packet, this will change to, for example, dot hash comma whatever to some values. So even if the packet is sniffed by the hacker, he'll not understand the values of this, because we have done integrity. Sorry, we have done encryption on this packet. He'll not understand it. So we make sure that we encrypt the packet so that the data is not disclosed to the unauthorized party. For example, in this case, we have this unknown person trying to sniff our packet. So encryption algorithms include DES, that is data encryption standard, triple DES, that is 3 times the data encryption standards, and AES, this is the advanced encryption standards. So these are some these are the things we have to think when we create a tunnel. So now that we have created our tunnel, we have to think about CIA, confidentiality, integrity, and authenticity. And for that, we use to secure our communication from Bangalore and Kashmir. We don't want anybody to sniff in the packet and check all the data, the credentials, the important assets, important documents of our company. We don't want any man in the middle to take those and leak those papers or documents on the internet, because most of the man in the middle attacks are happening in the inside network, or also on the internet. Anybody can sniff your packet on the internet if it is not in the secure encrypted manner. So it's important to secure your data when you're sending it out on the internet. And for securing our tunnels, we use some protocols to secure our tunnels. And the first protocol is IPsec, and let me write it down here. The protocols to secure our tunnel is IPsec, and the other is SSL or TLS. So for site to site, we basically use IPsec to secure our tunnel, because by creating VPNs, we are not encrypting or we are not doing any kind of hashing. So for security, we use some other protocols called IPsec and SSL. IPsec is for site to site and or site to multi-site, and SSL is basically for SSL, and TLS is basically for remote access VPNs. SSL and TLS are not different. TLS is the advanced version of SSL. So we don't say SSL and TLS. We say SSL or TLS, because TLS is the advanced version of SSL. So these are the two protocols that we use to secure our tunnel that we create from our private sites, between our private sites. So now let's talk about the two types of, there are different kinds of VPN. For now, we'll discuss about two. So let's talk about what are the two different types of VPNs. So one type of VPN is called routing-based VPN, and another VPN is called policy-based VPN. In routing-based VPN, the routing table decides what packets will go through the VPN tunnel. For example, GRE or DM VPN. So if we have created a tunnel from R1 to R2, we'll run routing protocols on this tunnel, and the networks defined in the routing protocol will be secured. For example, I've defined network 192.168.1.1 and 10.10.10 and 10.10.10.1, 20.10.2 to 20.20.21. Whatever traffic I'll advertise in the routing protocol, those networks, those IP addresses will get secured, will get encrypted and sent over the tunnel to our Kashmir site. So in this case, in routing-based VPN, the routing table decides what packets will go through the VPN. So some examples are GRE and DM VPN. The other type of VPN is policy-based VPN. In policy-based VPN, what happens is that we use the ACL to decide what packets will go through the VPN. For example, a LAN to LAN, or we can say site-to-site VPN, IPsec VPN, or SSL VPN. So what we do is we create some ACLs in order to define our interesting traffic. So I don't want all the traffic to get secured for going from Bangalore to Kashmir site. I just want, for example, 10.10.10.1 going to 20.20.20.1, I want only this traffic, this particular traffic to get secured and pass through the tunnel, and the rest of traffic I don't want to secure. So with the help of ACLs, we define our interesting traffic, and that traffic that we have defined in the ACL will get called in the crypto map, and that will get encrypted and sent over the tunnel in a secured manner. So in policy-based VPNs, we use ASILs to decide what packets will go through the VPN. And some of the examples are LAN-to-LAN VPNs, IPsec VPN, and SSL or web-based VPN. So this is all for this video. In the next video, we'll talk about cryptography methods, and we'll talk about some keys, asymmetric keys, symmetric keys. So I hope you like this video. I'll see you in the next one.